standard ACL, or you can say standard access list. Now for showing the standard ACL, we use some numbers by which router know this is standard list. These numbers are 1 to 99. These are number for standard ACLs. Standard ACL also have expanded range or expanded numbers in newer versions of iOS. That extended range of standard list is from 1300 to 1999. These are extended range also used by standard ACLs. By using numbers from 1 to 99 and 1300 to 1999, you are telling the router that you want to create a standard access list. So the router will expect syntax specifying only the source IP address in the test lines. Now I'm configuring a scenario like this. This is our router 1. This is our router 2. This is our network switch 1. This is our switch 2. These are hosts. This is a 12th network, 12.0.0.0/8. This network is 192.168.1.0/28, and this network is 192.168.2.0/24. This is also 24. Now this router has another network that is 192.168.3.0/24. There is a switch and hosts also. Let's configure it first. For configuring, we need to use Cisco Packet Tracer. In Cisco Packet Tracer, I am using 2800 series router. And this switch. This router have two networks like this. Now I am connecting these all with cables. This is not connected because this router have only two interfaces, two fast Ethernet interfaces. You can see here, this is our console port, this is our auxiliary port. These two are FE ports. So we need to add one more FE port here. We put it off by this button, and we add fast Ethernet port here. This is our fast Ethernet port. This is fast Ethernet port, yes. Now we give the power to the router. Now we can add fast Ethernet cable here. This router also connected with a switch. These switches have some hosts. Now I am using two hosts per LAN. These hosts are connected with cables to the switch. This is all whole scenario that we configure here. Now I'm giving the IP addresses. This is our 12th network /8. This is our 192.168.2.0/24th network. This is our 192.168.1.0/24th network, and this is 192.168.3.0/24th network. Now first I'm configuring the routers. Go to your enable mode, then configuration, then your interface mode. FS0/0 belongs to this particular interface, so I'm giving the IP address for this interface. IP address 192.168.1.1.255.255.255.0. no shut. Go to the second interface, that is FS0/1, that belongs to 192.168.3.0. Now I am giving the IP address of this range 192.168.3.1 255.255.255.0. no shut. Now moving the third interface, that is interface FA1/0. Give the IP address 12.0.0.1 255.0.0. no shut. Now I'm giving the IP address to these interfaces of the router 2. Go to enable mode, then configuration mode, interface FS0/0, IP address. I'm using 12th network here, so I'm giving the 12.0.0.2 as the IP. I'm done with my configuration. I'm giving the IP address to the host. This is my default gateway. I'm giving IP address to this host also, that is 192.168.3.3. This is subnet mask, and the default gateway for this PC is 192.168.3.1 because I'm giving the 3.1 IP here. Now configure this LAN for this PC. I'm configuring 192.168.1.2 because .1 is my default gateway, because I'm giving .1 IP here for of this router. This is my subnet mask, and the default gateway is 192.168.1.1. Same is applied on this host also. Now move to this LAN. Now I'm giving all the IP addresses to, but this PC cannot communicate with this PC because this router does not know about this network, so we need to use use routing here. I am using default routing here, and I am giving the default route to this link. Go to your configuration mode, and for default route just type IP route 0.0.0 and your exit interface, that is FA0/1. Now I'm giving a default route from here to here. This PC can send a packet via this link because this router have a default route. It send the packet here, but the reply does not come because this router does not know about these and this network. So we need to give a default route here also. Go to your configuration mode of router 2, just type IP route and the exit interface, that is FA0/0. Now all routing is done. It means all PCs can communicate with each other. Let's check this. I'm giving this PC to this. The first packet is dropped because of ARP. Now just wait a minute. Let's check what is the issue. This PC, show IP route. These are the directly connected network. It means it have the information for this directly FA0/1. Okay, I'm giving here 0/1 instead of 1/0. I need to give here 1/0. So go to your configuration mode again. Let's check what this is my IP route command. Yes, I'm giving the wrong command here. I need to use FA1/0. So go to your configuration mode, just type no and that same command. I'm denying that same command. I'm giving the command with a newer interface, that is 1/0. Now let's check and let's ping the PCs. Let's check what is the issue again. Show IP interface brief. This belongs to FA0/0, that is okay. This belongs to this is okay, this is also okay. Show IP route FA1/0, this is okay. Okay, now check on this router. Show IP route this FA0/0, this is okay. Now show IP interface brief. this PC, these PC can successfully connected with each other or can communicate with each other. This time this fail because are taking the time for this. I'm using ping command here. Open your command prompt, just type ping and the IP address of the destination, that is 192.168. I'm checking the IP of this PC. This PC have IP 192.168.2.5, so I'm pinging to 2.5 here. Yes, I'm getting the reply. It means our process is done here. You can check. These PC can communicate with each other. Yes, these PC can communicate with each other. Now we are moving to this LAN. These PC also can communicate with each other. These all PC can communicate with each other. The routing is done right now. Now I am using the ACL. The first one is standard ACL. For using standard ACLs, go to your configuration mode. Just type access list. Now you see here, this range is for standard ACL and this range for extended ACL. Now I am using standard ACL, so here I am using 1. Now you see here deny, permit and remark. If you deny something, just type deny. If you permit something, then you need to give permit command here. For example, I'm denying something, then I'm type deny. Then there are 3 options, A, B, C, D. It means address to match. You can deny a particular IP address, or you can deny the whole network is. The first option is the any parameter is used to permit or deny any source, host or network. The second one is any. Any means the IP address to specify any network or any IP address. The third one is host. Host command is used for a single host address. It means a single IP address. This is used for a network. This is used for a IP. This is used for any IP or any network. I am typing the host, or you can type the network of this, because here my motto is deny 192.168.1.0 to 192.168.2.0, but allow 192.168.3.0 to 192.168.2.0. It means, what I'm trying to say, these all PC, these all PCs, or you can say this LAN can communicate with this LAN, but this LAN cannot communicate with this LAN. So I'm creating an access list and I'm blocking this network or particular this network here on this router. If I'm denying this particular network, then this network cannot communicate with this network also. If I'm denying this network in ACL, then this network cannot communicate with this network also, because then I'm applying the ACL here and this particular interface or router deny all the packets of this network. Then this network can go through via this router, so this network cannot communicate this network also and this network also. So I'm applying the ACL on this router, or you can change the scenario like this. You can deny this network. You can deny this network here. But if you are denying this network, you need to apply ACLs on this interface FS0 by 0. If you apply the ACL that denying this network on this interface, then this network cannot communicate with this one also. So go to the scenario and create an access list here. And access list 1 deny this particular network, and the network ID is 192.168.2.0. Now I need to put wildcard bits, or you can say wildcard mask. The wildcard mask for /24 is, we already discussed how to calculate the wildcard mask and what is the use of wildcard mask. So in ACLs we are using wildcard mask or wildcard bits. These are the wildcard bits. This is the ACL. I am creating an ACL access list 1. That number is 1 that denies 192.168.2.0. It means this network, this whole networks. If I'm applying, for example, ACL denies this whole network. I'm creating ACLs on R1 and ACL denies this whole network. If I'm applying ACLs on this interface, then this network cannot communicate with this network also, because if this network wants to communicate with this one, it must need to go via this interface. But any packet that received on this interface, that is denied just because of ACL. So we need to apply this ACL on this interface. So here we go. This is ACL is created. Now we need to apply ACL on a particular interface. Go to your interface mode. I'm going to FA0 by 0 and just type IP access group. Now give the group number, that is 1. The access list number is 1 that I already created, so I need to use here 1 also. And here the option is in and out. In for inbound packets and out for outbound packets. I'm using in because the traffic comes from this is inbound traffic for this interface. So I'm using in here and press enter. But there is a problem. The problem is, you can see here, these PC cannot communicate now. Before applying ACL, these PCs can communicate with each other, but now these PCs cannot communicate with each other. You can see here all packets are dropped. But this wants to communicate with this one, then these are successfully sent. Now we are trying to communicate these two lines. These are failed. Let's check once again. Why they are failed? Because every ACL or access list have an implicit deny statement. I'm giving a command in ACL, that command is deny 192.168.2.0/24, and this is applied on this interface. But there is another implicit deny statement that says denied all other. If this packet comes to this interface, then this is denied by this line or this rule of ACL. If the packet that comes from this LAN, this is also denied because of this implicit deny statement. So here we use the last statement as allow all other. We need to use this statement here. So go to your configuration mode, just type access list 1 allow. For allowing, the keyword is permit. Here you can type any, press enter. Now the first statement of ACL is deny this network. It means this network is denied. Now the second statement of ACL is permit any. If we do not use this statement deny permit any, it means all other networks packets also denied. If you want to communicate all other networks to this particular network, so we need to use this command. Now for checking the ACL, the command is show access list. You can see here there is a standard IP access list. The number of ACL is 1. The first statement, this is 10 and 20 are numbers, that is random or the number that given by a particular algorithm to each and every line in ACL. This is first line, and the statement is deny this particular network with this wildcard mask. The second statement is permit any. You can see here, if I am giving any command, that is shown the next command, shown the down line or the next line of the previous one. This is our standard list. You can create multiple access list on a router, but on an interface you can apply only one ACL. You can, for example, you can create here 3 ACLs and you can apply 3 ACLs on different interfaces. If you are create the multiple access list, the whole access list, or you can see the all access list are shown here by this command show access lists. This is all about the standard IP access list or standard ACLs. Now we move to the second ACLs or second type of ACLs, that is extended ACLs.